It's another math day here with teacher Jenny. Join me for another topic. This time we're going to talk about continuity of a function at a number with a given piecewise function. Let us try to determine if the function is continuous at the given number c. For this piecewise function, f of x is equal to 1 minus x if x is less than or equal to negative 1. X squared minus 1 if our x is greater than negative 1. We are to check the continuity at c equal to negative 1. So let's try to check the different conditions. Let's start with f of c. If our f of c exists, we have f of negative 1. Choosing between the two functions here as to where negative 1 satisfies on the domain, drawing our number line on the first domain or first function, we have our basis as a negative 1. Looking at the symbol here, this is pointing towards the left side or to the left direction. We have equal symbol as well. That means to say that negative 1, this is included as part of the domain of our function. To the left of that one, we have negative 2, negative 3, and so on. Those are the values that will be satisfying the domain on the first function. And we wanted to know where negative 1 is satisfying. We have that equal symbol, so automatic we'll be using that particular function in checking condition 1. We have f of negative 1 equal to 1 minus x. Substituting negative 1, we have 1 minus negative 1. This is equal to 1 minus negative 1. This is leading to a plus because negative times negative, that's a positive. So 1 plus 1, that's equal to a 2. We have f of negative 1 is a 2. So we're done with testing the first one. Our f of c there exists. Our f of negative 1 exists. So we go to the second condition and checking on that. Take note, this is piecewise function. So we will be checking the limit of your f of x as your x approaches your c. C there is negative 1. We're testing on the left hand limit. So we have negative at the top, which means we are checking our limit as your x approaches negative 1 coming from the left side. Now again, we have two sets of functions there, so we have to choose as to what will be the function in which the values there are coming from the left side of negative 1. We are approaching from the left side of negative 1. And this one, this first domain is satisfying that one because most of the values are coming from the left side of negative 1. So we will be utilizing our first function. We've got limit of 1 minus x. As your x approaches 1 coming from negative 1 coming from the left side, we are now going to substitute. We have 1 minus negative 1. That's equal to a 1 plus 1. That is equal to a 2. Now next, we are going to check on the right-hand limit. So we have limit of f of x. As your x approaches negative 1 coming from the right side. So again, that's coming from the right side. So our first function is a no-no because the values there are coming from the left side of negative 1. So checking on the domain on the second function, if this is our negative 1, noticing that our symbol here is pointing to the right, which means that the values to the right of that one, like a 0, and in between those numbers, we have also a 1 here. It's moving to the right side of negative 1. Those are the values considered as part of the domain. But we do not include negative 1. So upon looking at that one, we know already what are those values that are coming from the right side and moving towards negative 1 from the right side. So that will be under domain 2. Second domain. or second function's domain. So we will be utilizing the second function. We have here the limit of our x squared minus 1 as your x approaches -1 coming from the right side. Since this is quadratic, our function there is quadratic, we do not see any problem at all when it comes to quadratic. So literally, whatever you substituted on your quadratic function, automatically will be getting an approach value on y. So that is why we have to substitute -1 on the function. We have x here, substituting -1 here. We square that one, minus 1. So -1 squared, that's 1. Minus 1 is a 0. So checking up between the right-hand limit and the left-hand limit, they don't have the same value. So therefore, this limit of our f of x as your x approaches to a -1 is a DNE. Now, since this is a DNE, our second condition is not met or is not met, automatic, we will not be proceeding to the third one because this is, of course, does not exist. We can only proceed to the third one if our limit here exists. Automatic, we have now the conclusion without undergoing the third condition that f of x is discontinuous at c equal to a -1. Now, the type of discontinuity here, if you have watched the video in which I've discussed there the different types of discontinuity in which we have the graphical approach, you can find it there. You can click on that video so that you will be guided as to how to identify the types of discontinuity here. But anyways, I'll just talk about it here a little bit. Now, if you've got there an existing f of c, but a not existing limit of a function, the type of discontinuity here is what we call as removable. Oops. Forgive me on that one. So as I mentioned, let me redo that. When you've got there an existing f of c, but your limit here is not existing, that means to say our type of discontinuity here is a jump or essential discontinuity. Again, if you've got an existing f of c and a non-existing limit, that means to say that a non-existing limit, meaning to say that the limit from the right hand and left hand do not exist. That means to say that the type of discontinuity there is what we have as the jump or essential discontinuity.